So hi everyone, I'm Paul Possa from Euresys, and today I will give you an update on CoaxPress-over-Fiber. During this presentation, I will try to show how this state-of-the-art standard can create new opportunities for high-speed vision. In my screen, I don't know if you can, okay.
We can see, I can see it. I hope everyone else can also see it.
Okay, perfect. So, Euresys is a leading designer and provider of computer vision components with almost 40 years of experience in this market. Our products include frame grabbers compatible with CoaxPress, camera link, and analog cameras. We also provide certified standard IP cores for GigaVision, CoaxPress, and USB 3 Vision. These IP cores are software components for FPGAs that allow our customers to integrate these standards into their cameras or embedded systems. And we also provide a set of image processing software tools and libraries that are mostly used in inspection applications. So this is the agenda for today's presentation. First, I will explain what is CoaxPress-over-Fiber and how does it work. Then I will give the status of the standard, and I will describe some target applications. And finally, I will present what Euresys can provide you to build your own applications using CoaxPress-over-Fiber. So what is CoaxPress-over-Fiber? In one phrase, CoaxPress-over-Fiber is an extension of the CoaxPress standard to support fiber cables. But in fact, CoaxPress-over-Fiber is much more than an extension. It is a way to run the CoaxPress protocol without any modification over standard Ethernet components. It keeps all the advantages of CoaxPress, such as high bandwidth, precise camera control with no jitter and low latency, and also low load for the host CPU. It benefits from low cost and easy to find standard Ethernet components, such as connectors and cables. And it also benefits from the continuing evolution of these components towards higher speeds. With CoaxPress-over-Fiber, we also improved the data integrity of CoaxPress because we have an additional forward error correction. So why we think that fiber optics are not just better than copper cables, but the only solution for some applications. Firstly, because fiber has unlimited bandwidth. To have an idea, today we can buy transceivers that can transfer up to 400 gigabits per second on a single fiber. It also provides virtually unlimited cable length. For example, for 40G, fibers have a cable reach that it's 1,000 times longer than copper. It is completely immune to electromagnetic interference. Fiber cables are also less bulky than copper cables. In this picture, we can see the difference between 4 cables of 50 meters on coax and 50 meters of multi-fiber cable with 4 pairs of fiber. Note that power over cable is not supported on fiber. In terms of bandwidth, today, the copper technology is limited to 12.5 gigabits per second on a single cable, which in a typical CoaxPress application with 4 cables, it gives us a maximum of 40 gigabits per second of bandwidth without the encoding overhead. On the fiber side, we don't have this limitation, and we have already components available that can go up to 400G or even 800G. So how does CoaxPress-over-Fiber work? We have here, let me just put a pointer. So we have here a quick comparison between CoaxPress-over-Copper cables and CoaxPress-over-Fiber. So for CoaxPress-over-Copper, we have the CoaxPress cores that handle the communication protocol. They are directly interfaced with the MGTs inside of the FPGA. MGTs are high-speed multi-gigabit transceivers used to serialize data in FPGAs. And outside of the FPGA, we have a set of cable drivers and equalizers to increase cable reach. For CoaxPress-over-Fiber, we use exactly the same CoaxPress cores to handle the communication protocol, but instead of interfacing directly to the MGTs, we use a bridge to map the CoaxPress protocol into XGMI packets. XGMI is a 10G on-chip interface, which corresponds to the entry point of Ethernet physical layer. Once we are in the XGMI domain, we can start using components compliant with the Ethernet physical layer. For example, PCS, PMA, transceivers, cables, and connectors. So now regarding cables and connectors, we have basically three options. We can use fully integrated cables where the cable length is predefined and fixed to the transceivers. They are quite practical, but the cable length is defined during production and we cannot change after production. The maximum distance for this solution can go from 100 meters to 300 meters, depending on the performance of the transceivers. Then we have the multi-mode MPO type, composed of three elements, two optical transceivers and one multi-mode MPO fiber cable containing multiple pairs of fiber. The maximum cable length for the solution can go from 150 meters to 400 meters, depending on the performance of the transmitter, the transceiver. And for extreme long distances, we have a single mode LEC duplex solution that is also composed by two transceivers and one pair of a single mode fiber. This solution target applications of up to 40 kilometers or even 80 kilometers with high performance transceivers. So now regarding optical transceivers, optical transceivers like QSFP+ are modules that transform electrical signals to light and vice versa. The QSFP stands for Quad Small Form Factor Pluggable. The quad means that these transceivers transform 4 pairs of electrical signals to light. The multi-mode MPO type are quite simple and less expensive than single mode ones because in MPO transceivers, each electrical signal corresponds to one fiber. So in QSFP+, we have 4 fibers in each direction. This also allows us to use breakout cables that split these 4 pairs into single pairs for multi-camera solutions. Then we have the single mode type, where we use a pair of fiber, one fiber in each direction. They are more complex than MPOs because they use a different light wavelength for each electrical signal. For QSFP+, we have 4 wavelengths that are multiplexed into a single fiber. And as I said, single mode transceivers are more complex and more expensive than multimode transceivers, but on the other hand, they use much cheaper cables and can reach longer distances. So now regarding the CoaxPress-over-Fiber standard itself, today CoaxPress-over-Fiber is presented as an addendum to the CoaxPress standard. It was enacted in 2021 by the Japan Industrial Imaging Association. There is an update to be released in few days, I think, because it's in the target is December 2023, where the CoaxPress Technical Committee defined the necessary registers to select the speeds corresponding to 25G per lane. And there's also some text clarifications. Also, the CoaxPress Technical Committee recently started working on a new CXP revision, the version 3.0, that will integrate CoaxPress-over-Fiber into the main document. We also see an increasing number of companies adopting CoaxPress-over-Fiber. In terms of applications, besides regular machine vision applications, there are applications that were simply not possible without fiber. For example, long distance applications where the host PC must be placed far from the camera, like for example in a stadium where we have several cameras placed far from each other, but the data must be transported to a central processing system, or even when we have a scene that has a high risk of explosion, or when the environment is simply not compatible with the processing system, like white rooms or high temperature or corrosive environments. And as I said before, fiber is much lighter than copper and can drastically reduce cable congestion. This is an example of a camera that migrated from 16 6x6 coax cables to only 2 MPO cables. Then we have applications in high EMI environments where fiber is simply immune to that. Also, in terms of bandwidth, CoaxPress-over-Fiber is today the only solution that can go beyond the coax limit of 12.5 gigabits per second in one cable. So finally, I will quickly present what Euresys can provide to build CoaxPress-over-Fiber system. First, we have this successful and prized CoaxLink USFP+ frame grabber. It was selected one of the most innovative products of 2021 by the Innovators Award program of Vision Systems Design. Then we have CoaxPress-over-Fiber bridge IP cores for both camera and frame grabber. These IPs are compatible with the main FPGA manufacturers like AMD, Intel, and Microchip. And they are delivered with working reference design and can greatly reduce time to market for new products using CoaxPress-over-Fiber. Now in our roadmap for 2024, we have the CoaxLink 6P12 to QSFP Plus converter that provides an easy way to extend the cable length via CoaxPress-over-Fiber. It is fully compatible with both CoaxPress 6P12 cameras and also with CoaxPress-over-Fiber frame grabbers. And it also provides power over CoaxPress to the CoaxPress camera. And finally, also in our roadmap for 2024, we have the next step in bandwidth for machine vision, the CoaxLink QSFP28 frame grabber. With this frame grabber that is under development, we can sustain a camera bandwidth of 100 gigabits per second, which represents 2.5 times more bandwidth than the CoaxLink QSFP Plus. And that's all. Thank you for your attention. And for more information about our products, please visit Euresys.com.